The systematic listing part 1 by Math Incubator. Systematic listing strategies. Factorial is n and then the exclamation mark. Factorial is defined as follows: n equals n times n minus 1 times n minus 2 times n minus 3, and so on until times 3 times 2 times 1 all the way to 1. Example is 5 factorial equals 5 times 4 times 3 times 2 times 1 equals 120. The arrangements. How many ways can the letters A and B be arranged? A and B and B and A, which is 2. 2 equals 2 times 1 is 2 factorial. In how many ways can the letter A, B, and C and D be arranged? I'm not going to say all of these for the sake of time, but there are 24 ways you can, which is 4 times 3 times 2 times 1 equals 24, which is 4 factorial. Formula. The number of arrangement from n different objects is simply n factorial. In how many arrangements can be made from the English alphabet? It's 26. 4. There are 6 red balls and 5 green balls and 4 blue balls in a container, and Sarah takes 2 balls from it. List all the possible combinations. Red, 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 green, red, blue, green, blue, green, green, and blue, blue. And there are 6 different arrangements. The numbers 3, 4, 6, and 2 are written out on 4 cards. How many 4-digit numbers greater than 6,000 can be made from them? 6,347, 6,374, 6,437, 6,473, 6,734, and 6,743. 3 factorial equals 6. The numbers 1, 2, 3, 4, 5, 6, and 7 are written on 4 cards. How many 7-digit numbers greater than 7,000 can be made from them? 7,342, 7,374, 7,431, 7,473, 7,674, 34, and 7,643, and so on. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, or just easier, 1 times 720 equals 720. The product rule for counting. How many positive integers with 5 digits can be made up using the digits 1, 2, and 3? Suppose we look for all the 2-digit numbers, then work up to 5. We can make a list: 11, 12, 13, 21, 22, 23, 31, 32, 33. So there are 9. The reason for this seems to be that there are 3 numbers that can go in the first place. For every number in the first place, first digit, there are 3 numbers that can go in the second place. 3 times 3 is 9. Okay, let's tackle 5 digits. There are 3 choices for the first place, 3 for the second, 3 for the third, 3 for the fourth, and 3 for the fifth. Altogether, we've got 3 times 3 times 3 times 3 times 3, which is 35, which is 729. A coin is tossed and a die is thrown. Find all the possible outcomes. I'm not going to read this either for the sake of time, but there are 12 different outcomes, which is 2 times 6 equals 12.
Carole, why did you write -2 times 6 equal 12?
No, this is just like to separate this. This is just to. It's not a minus sign.
Oh, okay.
2 dice are thrown. Find all the possible outcomes. 12 different outcomes, which is 6 times 6 equals 36. Again, this is not a minus sign. How many positive integers with n digits can be made up using just the digits 1, 2, and 3? 3 times 3 times, and so on, times 3, n time, which is n times. So the answer is 3n. How many words, strings of letters, most of the words are not in the dictionary, that can be made up from the letters A, C, and T if we use each letter only once. If you haven't met this type of problem before and have no strategy, then it's best, first of all, to use trial and error. So writing down all the possible words you can think of systematically gives ACT, ATC, CAT, CTA, TAC, and TCA. And thus there are 6 words. Alternatively, we can see that there are 3 possible choices for the first letter. Once the first letter is chosen, we have 2 choices for the second letter. Finally, there is only 1 possible choice for the last letter. Therefore, we can produce 3 times 2 times 1, which is 6 so-called words from the letters A, C, and T. Arranging objects with like objects. Rule is, if there are n objects with m likes, then the number of different arrangements are n factorial divided by n factorial. In how many ways can you arrange the letters m, n, n, and n? Is m, n, 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 m, n, 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 and n, 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 which is 4 ways. So how many ways can you arrange the letters B, B, and C? B, B, C, B, C, B, C, B, B. 3 ways. 3 factorial divided by 2 factorial. How many ways can you arrange the letters A, B, B, and A? A, B, B, A, B, 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 A, B, A, B, B, A, 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 B, A, B, B, A, A, B, which is 6 ways. This is 4 factorial divided by 2.